So this is what we're working on today. You also are going to need to have this, we're working on this packet today in class, lab chapters 7 through 9. So make sure you have this because we're going to be doing a few pages in here today, like 3 or 4 pages in here, the first 4 pages. So you need to have that. Again, that's the Notes in-class lab. It's your 3rd packet you got in that rubber banded packet that we had. So I'm going to talk a little bit about some things about Lab 5, and then we'll get into confidence intervals for proportions. I am going to get exam 2 graded. It'll take me a week, but if you guys only care about just your grade itself without the markups and the comments in the PDF, I can probably get that done by this weekend. In general, you should get more points, maybe between 30 to 50 more than your score. Part of that depends upon a couple different things, right? If partial credit is in there, depending on what you wrote down and other things. So, it's heavily dependent upon what you did. Plus, you're going to get 7 more points in the exam that are going to be graded for your picture of normal curves, right? For those four problems where you had to draw a normal curve, and 3 more points for your box and whisker plots. So currently, your score is really out of 90. This is 100 by the time I finish grading this weekend. All right, so Excel Lab 5 is due today. You can turn it in late for full credit on Tuesday. And then Thursday, you have your next Connect Math due 7174. Then next following Tuesday, you'll have Connect Math 7.3 due. Okay, so first I want to talk about a couple things. One is after class, if you have questions, feel free to browse on, don't write on, but browse on other people's Jamboards after class. That's totally free game. Like if you were like, I didn't understand how to do this, it looked like they got it, feel free to hop around and see what other people did. That's totally fine. Just don't go defacing their stuff or writing on their stuff. Only I can do that. Lab 5, I did not go over everything in Lab 5 in the video. I'm kind of making you be more independent. It's kind of neat. I've walked you through everything for the first 4. Now you kind of have a handle on Excel, and I'm going to have you guys be a little more independent. Read your instructions. So a lot of people had trouble trying to figure out how to do the binomial graphing and stuff like that. Read the instructions, and that's in problem. We'll talk about that in a minute, actually. And in the video, I just did the hard parts, the parts that people really struggle with. Those are the parts I did in the video. Lab 7 is going to be the same sort of thing. If you have questions after you watch the video and after you read through everything and try to figure out, feel free to come to my office hours and we can go over some stuff then. All right, Excel Lab 5, some comments on it particularly. So for the binomial tables, make sure you read number 2 on page 1. I'll show you how to do that one. And also answer the questions at the bottom of page 1. There's like 3 questions kind of ask you about, just general questions about those graphs. You can look at the numbers that you created and you kind of see from there how things go. So let's talk about some things that people struggled with. One was when n is 7, so assume n is 7, binomial n is 7. Would these 2 things be the same? Probability that x is these 2 things, what are they? Are they the same or not the same? So 15 seconds, think about whether or not they're the same. Everybody look at that. Are these 2 the same or not? These 2 things here, these 2 probabilities.
Not.
Okay, how are they different? Can anybody explain how they're different?
0, 1, 2, and 3, and then the other one is just 0, 1, and 2.
Mm-hmm.
So if it's equal to 3, the probability that x is less than or equal to 3, that one would be 0, 1, 2, 3.
Yep, perfect. Exactly. So what Grace was saying is that this one here is just 0, 1, and 2. It does not include 3. Whereas this one would include 3. This one would be 0, 1, 2, and 3. Great. Nice. And I can show you when I'm drawing this. So you're going to have this function called binom dist, binom dist. And you're going to give it an X and an N and a P. And then you're going to say true for if you want it to include the things that come before it. So if I put in the N and the P, if I put in, if I wanted just the 0, 1, and 2, I would put 2 in there. And it would grab, it would return, it would find the probabilities of these 3, add them up, and return that. If I wanted, so that would be the probability that X is less than 3. It would find these 3 probabilities and return that if I put 2 in for X. If I put in 3 for X, right? If I put in 3 for X, then it's going to grab all of these 4 here, find those probabilities, add them up. This function will, and will return the sum of these 4 probabilities. They'll add all 4 of them up. So that's how this function works. You'll see more about it when you get into it. So then my next question to you is, what about these ones? This is greater than. What numbers do we want for these? Remember, n is 7. What numbers do we want for these ones here? I want to take 15 seconds and think about what numbers we want for those. Okay, so someone share with me what numbers do we want for this first one? X is, remember, it's greater than 3 because the mouth goes towards the larger one. So what numbers are these ones? Somebody?
4,
Not Grace, somebody else?
6.
Yep. 4, 6, and 7. Don't forget n is 7. Oh, and don't forget 5. Come to 5. Right, so everything above 3. 4, 5, 6, 7. Good. How about this one over here?
3 through 7.
Yep, 3 through 7. Exactly. You guys got it. 3, 4, 5, 6, 7. Nice. Great. Perfect. So I'm going to actually go ahead and let me take a screenshot of that. Okay. So then, what if I only want numbers? So here I only want numbers 3, 4, 5, and 6. But here's my dilemma. I want these ones here. But this binom dist thing only gives me the numbers from 0 up to that number. So how can I get this red part using the binom dist function and other things, you know, add, subtract, multiply, divide, something like that. Someone take 30 seconds and try to figure out that. How could I, using the binom dist function, which uses from 0 up to a number, how can I find this 3, 4, 5, 6? Okay, anybody have any ideas?
Could you use the range feature in Excel?
Well, I want to use binom dist. I still want to use binom dist. Oh, you could use the range feature, but I don't want you to, I want you guys to think about it using some subtraction sort of ideas.
We calculate up to 2 and then subtract that from the total from 0 to 6.
Nice. Is that Jamila? Yeah, nice, Jamila. Okay, yes. So what Jamila is saying is that, let me get a different color. If I want the red part, I know that the red part plus the blue part, I can find the blue part because that's just binom dist of 2. Everybody understand that? It gives me from 0 up to 2. So if I want the red part, I can find the green part. And what do I know about the red and the green or red and the blue combined? If I add the red and the blue together, what should I get?
1.
1.
Purple.
Perfect. So if I take 1 and I subtract the blue part, I will get the red part. Does that make sense for people? 1 minus the blue part equals the red part. So you can make use of that in your lab 5. If not, you should come back here and watch the first, I don't know, 15 minutes of this video from this class. The other thing is, what if I want the numbers in the middle? So what's this probability that X is between 0 and 6? What are those? What numbers are those? Between 0 and 6, it's these 4 here. How do I get those using binom dist? So binom dist, I want to use binom dist in some way, adding, subtracting, doing something where I can come up with these probability of those 4 added up together. How many people do we have? Oh, we don't have very many people here. We only have 24 people.
They
Okay,
might have thought we didn't have class because you didn't give class for other classes.
I didn't what, huh?
Didn't you say there was a thing about flex day?
Yeah, that was Tuesday. I don't know.
Yeah.
All right, so I'm going to open up the groups. What you guys want to do is brainstorm for just a couple minutes, actually take 4 minutes. The first 2 minutes, I want you guys to introduce yourselves and share 2 things. Share like either how you're feeling about the class, how you're feeling about the exam, or how you're feeling about the semester in general, and maybe one other thing about yourself. So just everyone take like 30 seconds each and do that. And then take a couple minutes and think about how can I use binom dist, the binom dist function, which gives you a probability from 0 up to that number, to try to find this probability in blue. So that is your job. Try to figure that out. 4 minutes. Okay, so let me chat to everybody our links for the Jamboards. So the next 2 days, this class and next class, I'm going to put you guys into groups, randomly into groups, so you can meet new people. And then after next class, I'm going to try a spot where I try to let you guys pick your own groups, right? So we'll do it that way. We'll try that a couple times and see how that goes. And then maybe I have to assign groups or not, depending on how that goes. Okay. So let's go ahead and get back to where we are. Did anybody find a solution for this? Was anybody able to figure that out? Kind of a puzzle. It's kind of a neat puzzle.
I figured it out. I think you would find the probabilities up to 5, and then you would find all the probabilities up to 1. So basically just 0 and 1. And then you would subtract the first number from the second number, basically. Because in Excel, it won't let you grab the numbers in between.
Right. So you guys know that the yellow part is made up of the red part plus the blue part. I can find the yellow part, that's 5 or less. If I want the blue part, I can take the 5 or less and subtract the 1 or less, and I get the 2 to 5. Well done. Nice, Grace. Good job. Okay, so that is, let me take a picture of this too. Alt, print screen.
Professor Young,
Yes.
would it be incorrect if we use the binomial distribution range instead then?
I would like you guys to think about this. Now, you could have done it that way. I just wanted you guys to kind of think about, explore some different puzzle ways of doing things. So it would be okay, since I don't think I explicitly said not to. So yeah, that worked. Good deal. All right, so now we're gonna start in on chapter 7, confidence intervals. Everybody loves chapter 7. Here's the thing about chapter 7 is that it's pretty straightforward. You guys will like it. It's really important that you totally get it down well so that when we get to chapter 8, you don't get it confused with chapter 8, because that's the problem. Everyone's great with chapter 7. They love chapter 7, and they get to chapter 8 and they start confusing the two. So make sure you really get a good handle on chapter 7 so that when you get to 8, it doesn't, you don't get them mixed up in any way. All right, so the first question is, why do we take a sample? What are polls for? So example, I take a poll, Trump has a 41% approval rating. Why did I take that poll in the first place?
To make inferences or draw.
To make inferences, yes. Explain to us in layman's terms, what's an inference about? Right? Like,
to, I don't know, be able to kind of get a temperature or draw some kind of conclusion about the phenomenon you're seeing, but you can't measure everybody, so you have to measure the small piece.
does that make sense for folks? So she's saying we want to know what everybody in the whole country thinks about Trump. So it's why do I not want to? Why can't I just ask everybody? Why would I just ask everybody, everyone in the country?
Not everyone would answer.
Yeah, one, not everyone's going to answer. 2, it's heck of time consuming, right? It would take a lot of effort to ask everybody. So instead, what Jamila is saying is we just take a small chunk of it, a small piece of it. We take a sample, and then we make this inference. We make a guess about what the whole country thinks based upon this sample. So that's why we take a sample. Great, nicely done. Second question I'm asking you guys is, what does a proportion look like? Do you guys remember what a proportion looks like? Someone give me an example of what a proportion looks like. Anyone? What does it look like? Just
Like 2 out of 20.
yeah, great. 2 out of 20. Perfect. 2 out of 20. Right? 2 out of 20. Or it could be in words. 2 out of 20. Right? Or it could be so out of means divide by. 2 out of 20 means divide by 20. Just that's a good thing to kind of make sure you guys realize. Or it might look like a percentage. 2 out of 20 is 10%. Or it might look like a decimal, 0.10. Those are all proportions. Is everybody on board? Cool. Where does it come from? What kind of questions did the researcher ask the subjects? So you guys remember proportions? What were they last exam? Which ones were proportions? Does anybody remember? 2 out of 20. What kind of question was that?
That probability?
Yeah, which distribution was that? Do you guys remember?
Binomial.
Binomial. So what kind of questions are those? Are binomial ones?
Either or.
Mixed.
Either or, yes, no's, is, isn't. Yep, perfect. You guys seem to have all those. Nice. So these are the is, isn't. Do you eat pancakes or not? Was it a heads or was it not? You know, so the yes, no questions. Perfect. These are what we're looking at. So we're going to have 2 types of things going in. These proportions, the yes, no's, right? Only 2 possibilities. And we're going to have means. Means are where your numbers are numerical. Like the question would be like, how tall are you? So if I said, how tall are you? You wouldn't say yes, right? That's not a yes, no question. You give me a number. So if your answers are numerical, that's a mean. If your answers are yes, no's, that's a proportion. So we're going to be looking at proportions first, because those are a little bit easier as we start in on this. Let's get someone reading this one. How about, let's get somebody who hasn't. Ilya, go ahead and read for me.
Okay. Definition. A point estimate is a single value or point used to approximate a population parameter. When you graph a point on a number line, what does it look like? What should my point?
Hold on a second. So when you graph a point on the number line, what does it look like, guys? What does that look like? Here's the number line.
It's a dot.
It's a dot. Exactly. Thank you. It's a dot. Right. So I graph it, point on number line, and it's just a dot. So it's one number, just one single number. That's a point estimate, a point, right? A point estimate means one single point, one single number estimate. Okay, so keep reading.
Okay. What should my point estimate be? If I take a poll and 41% approve of Trump, what is my best guess of his approval rating?
Everybody, private chat me what my point estimate should be. What's my best guess of Trump's approval rating? Private chat it. Private chat it. 4 people, 5, 6. It's not a hard question. 7, 8, 9, 10, 11, 12. All right, so if I took a sample and my sample says 41% approve of Trump, my best guess is that 41% of the whole country approves of Trump. That's why I took the sample in the first place. So whatever you get from your sample, that's your best guess. That is your best point estimate. So if I take a sample, the sample proportion we call this p hat. It's a p with a hat over it. So you kind of think of it like here's p, it has a little hat on top, right? P hat. And then we talk about something called p naught after that. Who's ever heard of the phrase all is for naught? Have you guys ever heard of that? Have you heard of that one? All is for naught. That means that all is for nothing, not N-A-U-G-H-T, not N-O-T, N-A-U-G-H-T. It's English. It means not, nothing, not zero, nothing. So all is for nothing. So our sample proportion p hat, and then so we got our proportion we got from our sample is the best point estimate of the population proportion p naught. I'll also call this p. I'll usually call this p, but your book may call it p naught. They mean the same thing. P and p naught are the same thing. Some people call it p, some people call it p naught. It means your population proportion. This is a parameter, right, for the population, p naught. Sample statistic, p hat. My statistic is my best guess at the parameter. So I'm not going to ask everybody. I'm just going to take a sample. So you guys are filling us in here, right? Yes, yes. Okay. The sample mean, X bar, is the best point estimate of the population mean, mu. Okay. So again, my sample is X bar. That's a sample mean. I take the sample mean so that I can guess at what the population mean is. The population mean is a parameter. Sample mean is a statistic. I can find statistics. I usually find statistics so I can guess at what the parameters are. I take something from a sample to try to figure out what the population is. Population one would be. So sample mean I take to find what the population mean would be. Let's get someone reading this one. Olivia, can you read this for us? Olivia M.
Oh, sorry. I thought you said someone else's name. The Pew Research Center conducted a survey of 1,007 adults and found that 85% of them know what Twitter is. The best point estimate of P, the population proportion, is the sample proportion.
Keep saying, keep talking.
P hat
Good.
equals 0.85.
Great. All right, so my best point estimate of the population is what I got from my sample, p hat. How about this one? Zubair, go ahead and read for us.
An interval estimate or confidence interval of a parameter is an interval or a range of values used to estimate the true value of the parameter. And then
P naught or
P naught or mean.
mu.
Oh, mu, yeah. And then do you want me to read the next one?
Yeah, keep going.
This estimate may or may not contain the value of the parameter being estimated.
Great. So say, for example, how long do you guys think it'll take to drive on average, like averaging all the times, all the different times you can go? How long will it take you to drive from Las Positas College to Oakland Airport? What do you guys think? Give me some answers. Let's hear them.
Like a good hour and 30 minutes.
Hour and
That's
30
it.
minutes, okay.
I can
On
say that for
average,
experience.
okay. Hour and 30 minutes. Someone else.
It's depending on traffic because I live in Alameda. So
No. From Las Positas. From Las Positas to Oakland Airport.
Probably like an hour and 40 minutes.
It's
Sometimes
variable.
at midnight. You could go at midnight. You can go at 5 a.m. You can go at 5 o'clock. You can go at 6 o'clock. All these different times. On average, how long will it take people? I have an hour and 30 minutes. Someone else give me something else. Another time.
45 minutes.
An hour.
I don't know if
An
we-
hour. Someone else.
2 hours.
2 hours on
I
average.
don't know. I don't know. I'm sorry.
At midnight, I can get there in 22 minutes at midnight.
Oh, okay. Yeah, that's my answer.
22 minutes. All right. Who else?
I'd say 45, but also depends on how fast you're going.
Right. Depends on all sorts of things. On average. Okay. So say our average time. So we have a big range, right? People think different things. What if we say 40 minutes? Oh, 50 minutes. We'll say 50 minutes. 50 minutes. On average, 50 minutes. Everybody with me? That's my
Yeah.
best point estimate. Say I take 2 samples. And one time it takes me an hour and 20 minutes, 80 minutes, right? Another time I go and it takes me 20 minutes. So I take my 2 samples, I average them, I get 50 minutes. All right, so my best guess is 50 minutes. What do you think the chances that the actual true probability, if I average all the times that people go, is exactly 50 minutes? Exactly, to the second. What do you think the likelihood is that that's the actual mean time, average
It's
time?
likely.
Not very likely. Okay, 50 minutes. What if I do this? 45 minutes to 55 minutes. Think my odds have gone up now?
yeah, because you widen your time range.
Yeah, I give a little range. I take my best guess, 50. I go 5 minutes this way, 5 minutes this way, 45 to 55. What if I went a little bit further? 40 minutes to 60 minutes. What do you guys think now? Even more, is that more likely or less likely?
More likely.
More
More
likely.
So the bigger my confidence interval I take, bigger interval I take around my guess, I take a larger and larger confidence, the more and more likely that the actual mean is in there. Does that make sense? Everybody following me?
Yes.
That's what a confidence interval is. You take your best guess, and then you go a certain number of standard deviations this way, you go a certain number of standard deviations this way, and that's you're saying, I'm pretty sure it's in between these two spots here. That's exactly what a confidence interval is. So what we're doing is we are taking our statistic, what we got from our sample, and then we're figuring out we're going to go we're going to find our standard deviation, and then we're going to go a certain number of standard deviations. We're going to find the z-score of how many standard deviations, the percentage we want. And it's going to tell us how many standard deviations. Remember, z-score is how many standard deviations you are from the mean. The z-score will tell us how many standard deviations away we want to go. So we take our z-score, multiply by our standard deviation, and that's how much we go on either side of our statistic. We take our statistic, we subtract that amount to get the lower end, we add that amount to get the upper end. So it looks like this. Our p hat plus or minus, right, add and subtract the number of standard deviations we want to go on each side, multiplied by what a standard deviation is. For an x bar, we'll again take the number of standard deviations we want to go away from the mean and multiply that by what a standard deviation is. And that'll tell us how much we want to add and subtract to our mean to get those two upper and lower limits. All right, so let's talk a little bit about the confidence level, how we get these things. So you should have been able to answer these ones so far. We're down here on the left. Let's get a reader for this one too. How about Colleen, go ahead and read for us.
Do you want me to read the title as well?
Yeah, actually the titles are great. I love it when you guys read the titles because the titles are super important.
Okay.
Yeah.
Confidence level of an interval estimate. The confidence level is the probability 1 minus alpha.
Nice.
That the interval estimate will contain the parameter, assuming that a large number of samples are selected and that the estimation process on the same parameter is repeated.
Right. So what does that mean? So first of all, what's my guideline for unusual?
5% or lower.
5% or less, exactly. 5% or less is our general guideline for unusual. So that's what we call our alpha. Our alpha is typically 5%. Our guideline for unusual. Alpha is called our significance level, what we determine to be unusual. It's always alpha if nothing else is said by default. However, now you guys are getting more advanced. You can use an alpha of 10% or 1% or 2%. You can use it, you can pick your own alpha. So depending upon what you choose for your alpha, that will determine your confidence level. Your confidence level is the rest of it, what's on the inside. So if 5% is my alpha, then my confidence level would be 95%, because 95% plus alpha plus 5% equals 1 or 100%. So what would be the confidence level for, if alpha was 10%, what would be my confidence level, guys? Tell me.
90%.
90%. 10% would have an alpha, alpha of 10% would have a confidence level of 90%. Okay, everybody private chat to me, if I had a confidence level, an alpha of 1%, what would be my confidence level? Private chat it. 2 people, 3 people, 4, 5, 6, 7 people. Only 8 people know. 10, 11, 12. Confidence, alpha of 1%, what's my confidence level? Only 15 people. Only answer once. Okay, you guys have 5 more seconds to answer before you lose a point. Participation. If my alpha is 1%, what's my confidence level? 5, 4, 3, 2, 1. Okay, it's 99%, because alpha of 1% means a confidence level of 99%. They add up to 100%. Okay, good. Please note it's important to interpret them correctly. So, for example, here's my confidence interval from 0.828 to 0.872. It's correct to say we are 95% confident that this interval actually does contain the true value of the population proportion. It does not mean that there's a 95% chance the mean is between these two. Either the mean is or it isn't. What it means is that if I do this process over and over and over again, 95% of the time, if I take a sample, take another sample, take another sample, take samples over and over again, 95% of them will have, when I find the confidence interval, will include the mean. So here's a picture of what we're talking about. So these are all different samples. I take a sample, the red dots are all the samples. So I take a sample, I take a sample, I take a sample, and then I find the confidence interval around that sample. Right, so the blue lines are the confidence interval around the samples. So here I've taken 9 samples. Most of them include the mean. Here's the actual mean.
Professor, I don't think you're sharing your screen.
Yeah.
Oh, shit. I'm so sorry. Haha. Okay, let's try that again. Thank you.
LOL.
All right, let's try this again. All right, so here we're 95% confident the interval between 0.828 to 0.872 actually does contain the true value of the population proportion P. What that means is it does not mean there's a 95% chance that the mean is in between these two numbers. It either is or it isn't. What we're talking about is it's the success rate of the process, right? So in other words, the process being you take a sample. Randomly, you take a sample. You're going to get something different each time you take a sample, just due to randomness, right? And then you take a confidence interval around that sample, around each one of these samples. 95% of them will include the actual true mean. However, 5% of the time, you're going to get a weird sample. It's just going to happen. That's just how life goes. 5% of the time, you're going to get a weird sample, and that weird sample will not include the mean. So this 95% confidence interval refers to there's a 95% chance that your sample was not strange. Does that make sense? There's a 95% chance that your sample was usual and not unusual. There's a 5% chance that you got an unusual sample and you'll be out here. So there's a 95% chance that your sample's good and that the interval does include the mean. That's what this 95% confidence means. Thank you for pointing that out, by the way, that I was not on there. You guys are great, thank you. Perfect. Let's get someone reading this one. Serena, go ahead and read for me.
Critical values. A standard z-score can be used to distinguish between sample statistics that are likely to occur and those that are unlikely to occur. Such a z-score is called a critical. Oh,
sorry. Keep going.
A critical value. Critical values are based on the following observations. 1, under certain conditions, the sampling distribution of sample proportions can be approximated by a normal distribution. 2, a z-score associated with a sample proportion has a probability of
alpha over 2?
Alpha over 2 of falling in the right tail.
Perfect. So these two things, we can do this because of these two things. One, you guys remember central limit theorem? It says that even if your data is not normal, it's not normally distributed, you can use a normal distribution if you take a mean of a sample of 30 or more. Because the mean of a sample of 30 or more, those means will be normally distributed. So if you're working with means, mean of the means, right? Means of 30, means of a sample of 30, then those will be normally distributed. And then the other thing is that we have these z-scores. You can find the z-score that matches up with alpha over 2 being in the right tail. So in other words, we know that, for example, 95% of data lies within how many standard deviations of the mean, guys? 95% of the data? Anyone? Bueller?
2.
2.
2
right.
standard deviations.
Right, so 95% of our data lies within 2 standard deviations of the mean. So if I want a 95% confidence interval, I just have to go 2 standard deviations away from the mean in either direction. That's the z-score I'd use too. Actually, it's a little bit, we're gonna go a little bit finer now. That's the approximation under empirical rule. It's actually 1.96, which we're gonna see in just a minute. So here, we call these things critical values. They are z-scores. Here's a critical value. This z-score that separates the usual area from the unusual area in red. Right, so our guideline from usual is 5% or less, right? That means my alpha would be 5% or less. Remember, if 95% is on the inside, 5% is on the outside, but half is in each tail. So 2.5% would be over here, 2.5 would be in the red group over here. Half of my 5%, half of alpha. So let me ask you one question. Alpha is a probability. So it is a blank. Probabilities are what when we talk about normal distributions? Everyone private chat to me what that is. Alpha is a probability. So in this drawing, it would be what? It's a 1 person, 2 people, 3 people, only 3 people know. Probability is the same thing as what? Only 6 people know, 7 people? Oh, I'm worried. Okay. Probability is the same thing as what? Let me give you one thing. It's the same thing as percent of population and the same thing as, there we go, now we're getting it. Someone just take a guess, take a shot. Yep, relative frequency as well. So probability equals percent of population equals relative frequency and also equals area under the curve. So that's what we, that is what we're looking for. It's the area underneath the curve. So in this case, Alpha is a probability, so it's an area. It's an area. Alpha is the area in the tails of the curve. In the outside, we'll call it that way. Beyond our critical value. Beyond. All right, so here's my critical value. My critical value is a z-score that separates the usual area from the unusual area. And my alpha is the area kind of beyond that. So over here on the right or over here beyond it on this side. Just grab that real quick. Oops. Oh shoot, I didn't grab it. Okay, no worries. All right. So here you guys can see confidence level, 95% confidence level. You guys are kind of familiar, 95% is on the inside, 5% on the outside. That means that 2.5% is on this, on the upper half, and 2.5% is on the lower tail. As you guys said, it's roughly 2 is the z-score for here. It's actually 1.96 to be exact. So this one over here would be negative 1.96. So these are our z-scores that cut off between the inside 95% and the outside 5%. We call this Z alpha over 2. I call it critical value. They're the same thing. Z alpha over 2 and critical value are the same thing. How do you find them? This is easy. I give you a table. Just look right here on your table. They are right there. So here, if the confidence level is 95%, my critical value is 1.96. My confidence level is 90%. What's the critical value I should use?
1.645.
1.645. Just look it up. That's how you find your critical values. All the ones we're going to need for this class, for in class and the exams are right here. 90%, 95%, 98%, 99%. We're not going to use anything else but these 4 in class.
Do we have to memorize those, or will we be given the table?
You'll be given the table. Yep. So on the exam, you can use the table. They're actually at the bottom of your T table. We'll talk about that next class, I think, or maybe in about 3 classes, actually, possibly. Okay. However, there is one homework problem that will give you a weird confidence level and ask you to find the critical value. So that's going to be, it'll be like, it'll ask you to find the critical value for a 93% confidence level or a 94% confidence level or something like that. This is how you do it, just so you guys know how to do it just for that one problem. So if I want for a 95% confidence level, or say a 90%. Well, I'll do the one for 95%. 95%, my alpha is 0.05. That's the area in the tail. So how much is in each tail? Half of that, right? So I'm going to do inverse norm, second vars of, because I have it, I'm given an area, alphas are an area, and I want to find the z-score that goes with it. So I'm going to use inverse norm, second vars inverse norm of half of alpha, because this alpha, 5% is total, but 2%, 2.5% in each tail. So I'm going to do 0.025. And I will get negative 1.9599, if I round 1.96, negative 1.96. For the critical values for these guys, just grab the positive one, because it's going to be positive, negative, so it doesn't matter whether it's positive or negative. Just for simplicity, just write down the positive number. Good, everybody on board? So for confidence intervals, our critical values are always going to be positive, negative, doesn't matter. In chapter 8, our critical values will be positive if it's on the right side, negative if it's on the left side. So you just make it negative if it's on the left side, but you just make it positive if it's on the right side. But for chapter 7, it's always going to be centered, right and left. So you'll have both a positive and a negative. All right, so you guys bust out your calculators and find the critical value for confidence level of 90%. So do it, so you can do it once in class, so you can do it in your homework without having any issues. Everybody find it, do it now. What'd you guys get? So first you find your alpha 90%, your alpha is 10%. Am I gonna use 10%? Inverse norm of 10%, what am I gonna do?
You're gonna take half of 10%.
Because remember, we're splitting it up. That alpha is split up, half in each tail, half on the left, half on the right. So if I split that up, how much will I have?
0.05.
0.05, perfect. So it's gonna be 0.05 over here. I need to figure out the z-score that goes with 0.05 in the tail. So I'm gonna do inverse norm of 0.05, second vars, inverse norm, 0.05. And you guys should get negative 1.64, if you round 645. Everybody on board with that part?
Yes.
Okay, good. All right, so that's how you do it for that one homework problem. Otherwise, I'm going to give them all to you. Terrific. So this is your next, actually it's not, this is not on your notes, but go ahead and read it. Ale, go ahead and read this one.
Definition: when data from a simple random sample are used to estimate a population proportion, P, the margin of error, denoted by E, is the maximum likely difference with probability 1 minus A, such as
Alpha, that's alpha.
0.95 between the observed proportion, P hat, and the true value of the population proportion, P.
Perfect. So what we call that difference between those two is the margin of error. So this is on your notes. Danny, go ahead and read first.
Margin of error for proportions. The margin of error E is also called the maximum error of the estimate and can be found by multiplying the critical value and the standard deviation of the sample proportions.
Great.
E equals,
I'm going to read this. Yeah, go ahead and read the formula for me.
E equals CV
critical value
of critical value to the square root of P hat times Q hat over N.
Perfect. Great. So this is in your notes. You guys should be doing it in your notes. It is right here. You're filling in these blanks here. The margin of error E. What is that? It's the part I'm adding and subtracting. It's my critical value, the number of standard deviations I'm going away from the mean, multiplied by what a standard deviation is. So for a proportion, our standard deviation is square root of P hat Q hat over N. If you kind of remember before, for a probability distribution, it was square root of PQN. That was for, considering the whole sample size. Now I want to know how much should just one of them vary. So I need to divide that by N, which means I'm going to divide by square root of N squared, which means the N's would cancel out. I still have an N left on the bottom. So this is how you get it. If you really want to go through it, I can show you a whole proof of that. It's a little more complicated, but to simplify it, this is how you find your standard deviation for one, how much one should deviate. All right, so here, these are some other things you should be filling in down in here. Confidence interval for estimated population proportion P. P or P naught is the population proportion. You can also call this P naught. P hat is the sample proportion. N is your sample size. E is your margin of error. And CV, someone pointed out that CV is the same thing as something you guys used last exam, but I'm not going to use that ever again. You're never going to use CV from here on out in my class. Always means critical value, period. That's the same thing as the Z alpha over 2. And like I said, your book will call it Z alpha over 2. To save yourself a lot of head banging and confusion and stress, remember that Z alpha over 2 is just your critical value. Don't complicate it. It's just the same thing as your critical value. Otherwise, people start getting confused and they start trying to multiply by alpha and dividing by 2, and all sorts of trouble ensues. This alpha over 2 is just a label. It just means it's the Z-score. It's just like Z-score of Andy or Z-score of John. It's Z-score of alpha over 2. It's just a label. So it just means the Z-score, if you find alpha and divided by 2 and found the Z-score for that, that's the Z-score. Okay, so you should have filled in this part here. Now we're going to move on to talking a little bit about these guys in here. So a couple things you need to have. One, obviously your sample needs to be a simple random sample. And then you also have to match the conditions for binomial distribution, fixed number of trials. There's only 2 categories of outcomes, either it is or it isn't. And then steps 3 and 4, the probabilities have to basically stay the same, which means they're independent. Also, you need to have at least 5 successes and 5 failures in your sample. All right, so confidence interval. Again, you take your statistic, in this case, P hat, and you're going to add and subtract your error, which is your critical value, the number of standard deviations you want to go away, away from the mean, multiplied by what a standard deviation is. So that's your critical value multiplied by standard deviation of proportion is square root of P hat Q hat over N. So think of it as statistics plus or minus your error. So find your error, your critical value times your standard deviation, critical value times square root of P hat Q hat over N. Find your error, and then you're going to take that P hat and you're going to subtract the error to get your lower limit, and you're going to add your error to get the upper limit. And that's how you get those. So your error is equal to, again, your critical value times your standard deviation. Everybody good with that part? Do you understand what I'm saying? Let me explain it to you better. So here's your best guess. You have your best guess right here. So what was our best guess? Guess was 50 minutes, right? We found our error. Our error is 10 minutes. So I'm going to go 10 minutes this way, 40 minutes, and then I'm going to go 10 minutes this way, 60 minutes. So take 50 minutes, subtract 10 minutes, take 50 minutes, add 10 minutes. And then I have this 40 to 60 minute interval. That's all you're doing is you're taking your best guess, you're subtracting the error to get your lower limit, and then taking your best guess and you're adding your error to get the upper limit. That's all there is to it. It's not super complicated. It's pretty straightforward. What is your error? It's how many standard deviations away you want to go, multiplied by what a standard deviation is. It's not complicated. It's just this part right here. CV times square root of P hat Q hat over N. Okay. So this is just, again, reiterating, how do you find confidence interval? You can either write it. So the confidence interval says that your true proportion should be between a P hat minus the error and the P hat plus the error. Please note we are estimating P. We're not estimating P hat. I know P hat. I found P hat. I don't need to estimate it. I found it. What I'm estimating is the true proportion of everybody in the country. That's what I'm trying to figure out, P. So let's get someone to read the blue part here. How about Tate? Can you read the part in blue?
2016 election had Clinton 4 points above Trump. If you were to consider just the two of them, P hat equals 52% with E equals 1.5%. 50.5% is less than blank. Less than 53.5%.
What should go inside of here? Private chat to me what you think should go inside of here. Or what's going on? We had an election. Clinton's approval ratings of 52% with an error of 1.5%. So here's my interval. What should go inside? What is inside of this? Either in words or in symbols. Private chat to me what should go inside of there. Only 7 people are responding? 8 people? Take a guess. Okay, so my error is 1.5%. What am I saying is between these two? What's between these two? Read the thing. 2016 election. Clinton's approval rating was 52% with an error of 1.5%. So what's in between here?
Fiat.
A good guess. If I put p hat in there, what's p hat? 52%. All I'm telling you is that p hat is that 52 is between 50 and 53. You already know that. Everybody should know that. I'm not trying to guess at what p hat is. I know what p hat is. This is what I'm saying is, so think back to my interval of 40 minutes to 60 minutes. What's between 40 and 60 minutes? Well, okay, sure, 50 minutes is, but we already know that. You're not telling me any information, tell me that, hey, by the way, 50 is between 40 and 60. Everybody knows that. What am I saying? What useful information is that I'm telling you is between 40 and 60? 40 and 60 should be what? I'm guessing it should be what?
The mean.
Yeah, the mean time it takes to get from Las Positas to the airport. Does that make sense? The actual mean, not what I got from my sample. I know what I got from my sample. LPC to the airport on average should be between 40 and 60 minutes. That's what should go inside of there. So in this situation, it should be P, the actual percentage of people, not just what I got. I know what I got. I know P hat, it's 52%. That doesn't give me anything new. P, the proportion of people in the United States, right? P, proportion of Americans who will vote for Clinton. That's what they were trying to estimate. They're saying that the proportion of Americans who will vote for Clinton is between 50.5% and 53.5%. Were they accurate? Anybody?
Depends on electoral college or.
Yeah, right. There are a couple things going on there, right? So one was the issue that the electoral college screws things up. So even though she won the popular vote, she did not win the election. It was really close. I think it might have been just south of here. Why was their guess off by so much? Their guess was off by so much because they didn't take a great sample. Right, so that's the other problem with the sample. One of my friends asked me, she said, well, you do statistics. What's the probability that these polls that Biden is ahead of Trump by 20 points, how accurate is that? And the problem is that it may not be very accurate at all because people may lie and say that they're voting for Biden when they're not, when they're actually going to vote for Trump. Or people who are going to vote for Trump may say, F off, I'm not going to answer your poll at all. So they're just getting excluded from the poll entirely. Or people who are voting for Trump may not even be asked in the poll because they may not be in whatever spot that people would be to ask them. So they may not even be being asked. So that's the issue, is that we really don't know who's going to win the election because the polls are not taking a very accurate sample of who's actually going to vote, right? Because one, they're not necessarily asking everybody. Two, the people they ask may be saying, screw you, I'm not going to answer. And three, the people who are answering may be lying about who they're going to vote for. So we don't really know. That's the issue with the polls, is that there's all sorts of inaccurate, it's really hard to get an accurate sample. But again, what my point of this is, what we're trying to guess inside of here is P, the proportion of people in the whole country who are going to vote for Trump or going to vote for Biden or whatever. So you guys understanding what we're saying? P is what goes inside of here. We're trying to guess at what the whole country is going to say. Not P hat. I know what my sample was. I don't know what the whole country is. That's what I'm trying to estimate. Okay, so it's P that goes inside of here, not P hat. I know P hat. I don't know P. The whole confidence interval is to estimate P. So you can either write it this way. So this is what you should have. Don't write it like this. I want you to do the actual, don't be lazy. Do the addition and subtraction and find these two numbers here, right? So P is either going to be between this, P hat minus E and P hat plus E, or you can write it this way, where you put P hat minus E, comma, P hat plus E with parentheses around it. This is what we call interval notation. You take your lower limit, comma, your upper limit in parentheses. So either one of those will work. This is the easiest way to write it, and that's kind of the most common way of writing it also. Round-off rule for confidence interval estimates of P, round them to 3 sig figs. So take a look at this. How many sig figs is this? Anybody, everybody? How many sig figs is that?
5.
5. Okay, so how do you get to that? You take the first non-zero and start counting from here. So this is going to be 1, 2, 3, 4, 5. This is 5.
In my chemistry
Great.
class, it says the leading zeros don't count. So
exactly. So you go down until you get to your first non-zero number. The thing is that people don't really know what leading zeros mean, but yeah, you go down till you get to your first non-zero number. You start counting from there. 1, 2, 3, 4, 5. 5. So I want you guys to how would you write this in scientific notation? So that's the thing. The easiest way of doing this is writing this in scientific notation. So if I were to do this in scientific notation, you go to the first number. You have one number in front of the decimal place, so it would look like this: 2.1036 times 10 to the, let's see, 1, 2, 3, negative 3. In other words, what your calculator would give you would be this: 2.1036 e negative 3. That's what your calculator would give you. What does that mean? It means when you write it down in regular form, you write down 3 zeros and then your number. Oh, it's supposed to be a 6. Sorry, my bad. And then you write down your number after that. So 3 zeros and then your number. And then you put the decimal place after the first 0. Everyone see that? So this is how your calculator would give it to you. So e negative 3 means it should be smaller, right? So you put 3 zeros first, then write your number, and then put decimal place after the first 0. You guys round to this one to 3 sig figs, and then round this one to 4 sig figs. Do it on your paper. Do this one first, 3 sig figs, and then private chat me your answer. Private chat it. Only 3 people? 3 sig figs. Give me, round this to 3 sig figs. Give me your answer. 4 people, 5, 6. Come on, guys. Only 10 people? That is not enough people. Come on, I'm waiting for you. Not scientific notation. Give it to me in not scientific notation. Give it to me the number what it should be with 3 sig figs. Oh boy, we're in trouble. Okay. So 3 sig figs means that I am going to go to the first non-zero and start counting from there. So here's my first non-zero, 2. Start counting from there. 1, 2, 3. I'm going to stop there. Look at the next number. If it's 5 or more, you round up. If it's not 5 or more, you round down. So is this one, is the next one 5 or more? Is it 5 or more, guys? What do you think? Yes or no? No, so I'm going to round down. 0.00210. That is it. Okay, so everybody round this one to 4 sig figs and private chat me your answer. Do it now. This one, 4 sig figs, private chat me your answer. Do it. Do it. I'm going to chat to everybody our link to the Jamboards because you'll need that pretty soon. Okay, good. That's much better. Nice. Excellent. So it is, again, you're going to start off with, you're going to go down to your first non-zero number. So here's the first non-zero, and you're going to start counting 1, 2, 3, oops, 3, 4. Oh. And then you're going to look at the next one, which is the 6. I'm going to round up because it's more than 5, or 5 or more, sorry. So I'm going to end up with 0.002104. Good. Any questions on this before we move on? Find the. All right. And then I can clear this. All right, so here's the procedure for constructing your interval. First, you need, well, first of all, what you need is you need p hat plus or minus e, right? You'll write it this way: parentheses p hat minus e, comma parentheses, I'm sorry, comma p hat plus e, and parentheses. So in parentheses, p hat minus e, comma p hat plus e. In order to do that, you need p hat and e. P hat I'm going to give you. You'll be given p hat. You'll also be given n. So for e, I need to find my e though. My e is my critical value times the square root of p hat q hat over n. You're given p hat, you're given n. How do you find q hat? What's q hat? Anybody remember?
1 minus p hat.
Yeah. So p hat equals 1 minus, sorry, q hat equals 1 minus p hat. P hat. Great. So then that gives you the stuff inside the parentheses, right? Because you're given p hat and n. The critical value, how do I find the critical value? Look it up on the table. Did you guys all hear me? Again, how do you find critical value? Look it up on the doggone table. Super straightforward. Just go over to your table, scroll up and say, oh, right here. If it's 95% confidence interval, critical value is 1.96. It's a 99% confidence interval, our critical value is 2.575. It's just right there. Super straightforward. Just find it. Good. All right, perfect. So that's all you have to do to find the critical value. Just look it up on the table. So now we're going to go ahead and do this one. Let me get someone reading this. How about Malaya? Go ahead and read for me.
Example. In the chapter problem, we noted that a Pew Research Center poll of 1,007 randomly selected adults showed that 85% of respondents know what Twitter is. The sample results are n equals 1,007 and p hat equals 0.85.
So first, find the margin of error. So first thing I want you guys to do is figure out, I need to know what n is. I need to know what p is. P hat, sorry, p hat. And I need to know what q hat is. And then I need to know what my critical value is. So those are the things I need to know. Well, the first one, this one I'm not given that one. So these two things I'm given. from the beginning. So someone please help me out. What's my N?
1007.
Yeah, that's the number of people that you selected. Your sample size. N is how many people that you chose. I chose 1,007 people. Everybody good with that part? So let me do that in different color. My sample size, oh, okay. So much for that. So my sample size is 1,007. What is my p hat?
0.85.
0.85. All right, so everybody, if my p hat is 0.85, chat to me what my q hat is. 3 people are paying attention. 4, 5, 6, 7, 8. You guys, this is not so simple you can't pay attention. You guys got to stay with me on this one, right? Great. So nice, everybody seems to have it. If my p hat is 85%, my q hat is the rest of it, 0.15. It's the same as binomials, right? Mind our p's and q's that add up to 1 or 100%. So my p hat's 85%, my q hat is 15%. All right, great. Now I need to find the margin of error that corresponds to a 95% confidence level. So 95% confidence level, my confidence level is 95%, right? My confidence level equals 95%, which means that my alpha is 5%. Just so we're kind of clear on that one. Alpha is 5%, 0.05. And my critical value is what? You guys all have a table. Find the critical value, CV. It's different than my confidence level. Slightly different. What is it?
1.96.
How'd you find it?
I used your table.
Use the table. It's so easy. Just look it up. So everybody hop into your table over here. 95%, 1.96. Good so far? 1.96. Good. Look it up in the table. So maybe I should write that in there. Look up in table. Okay. And I'm going to take a picture of this one for the people at home or people who are looking. If you want to look back on this later, you can find this in the notes. It'll totally be there. I'm doing print screens of all these. Okay. So now I'm going to clear this in 5, 4, 3, 2, 1. And we're going to take a look at what we're doing. All right, so here are all my pieces. My error is my critical value times square root of p hat q hat over n. So my critical value is 1.96, my p hat is 0.85, my q hat is 0.15, my n is 1,007. This is how you do it. Work from the inside out, right? So calculate from inside out. So do inside of square root first. That is my hint to you. So I'm going to bust out my calculator. Oops, no, I'm not there yet. Bust out my calculator. And I'm going to start off with the inside. So what's in my inside? 0.85 times, go ahead.
Times 0.15.
Yep. 0.85 times 0.15. So find the numerator. First, find your numerator. And then my denominators are, and then find your denominator, which I already found. So find your numerator first, find your denominator next, and then divide them. So my denominator is already fixed, so I'm good there. So I'm gonna take my numerator, I'm gonna divide by
1,007.
1,007. Perfect. Now, see how this e-4? I don't really want to screw with this now because the e never -4, then I got to draw zeros and decimal places, and it's a whole big pain in the butt. So I want to leave it like it is. I need to square root this. Focus, guys. I need to square root this. The easy way to square root this, square rooting is the same thing as raising to the 1/2 power. So I'm going to raise it, caret up to the 0.5 power. And you'll see it just takes whatever answer I had before and raises it to the 0.5 power. So I don't have to retype it all over again. So then I get this answer. That's my square root stuff, and then I just multiply by 1.96 times 1.96.
Professor?
And that's where they got the 0.0, that's where they got this long number here. Yeah.
So when we square root to 0.5, can we do square root of 1/2 or 1 divided by 2? Because that's what I did and I got the same answer.
Oh, you did, wait, what did you do?
I did the square root of 1 divided by 2, so 1/2. It's the same thing. I was just curious if that was okay.
Oh, you mean you did raise it to the 1/2 power?
Yes.
Yes, you could, it's the same thing, yes. Instead of 0.5, you could do parentheses 1/2. So let me make sure I know what you're talking about here. Hold on a second. Let me just get this over here. So what you did was you did this. You did 0.175 divided by 1007. And you did raise, did you do this? Or yes or no?
Yes.
And then you did 1/2?
Yes. I just put 1 divided by 2, and then I got the same answer.
Right. If you have a fancy calculator, it'll do that for you. If you don't have one like me, I have to put the 1/2 in parentheses.
Okay.
If you have a fancy calculator where it jumps you into a little box, which I'm guessing is what yours did,
yeah,
then you can do that. If you don't, you have to put parentheses around it, or else it'll raise it to the square, it'll raise it to the 1 power and then divide by 2. Do you see what I'm saying? So for me, I have to do this, because if I don't, it will do, if I don't put parentheses around it, I'll show you what it'll do. It will give me, he'll just divide it by 2, which is not what I want. It just divided it by 2. Do you see what I'm saying?
yes.
So it raised it to the 1/2 power and then divided to the 1 power and then divided by 2. So if you have a fancy calculator, you can do that, or you can put parentheses around this. The other thing you can do is you could do this. Here's my answer. You can do this instead. Square root. So second, do you see the square root here in blue? You can do second square root. So it's going to be this x squared thing here. And then you want the old answer. So you do second, and you do the answer key, which is down here, this next to the enter key, down here, this little ANS down here in blue. Click that one, second, and then that will give you the answer. And you see it says answer right there. And you can do it that way. You can do that also. So that's the other way that you can do this. So either one of those will get you kind of what you're looking for. And then don't forget to multiply by 1.96. Right, so either one of those totally works.
Thank you.
Sure. All right, good. Back to here. Should I put that in there about raising to the square root power? Do you guys want me to do that? To square root, raise to the 0.5 power. And I'll do it like this. Caret 0.5. That'll be my suggestion. All right. Okay, good. So once we found our confidence interval of, or sorry, our error of 0.02205545, you're just going to take our p hat, 0.85, subtract it. That's our lower limit. Round it off to 3 sig figs. Take our p hat, add our error, and then round that off to 3 sig figs. And p is between these two. That's it. Straightforward. Just that. All right. So you guys should be writing this down. So you guys are all writing this down on your notes, right? So this should be written down in your notes here under B. You've written that down, hopefully. And then next is C. Based upon the results, can we conclude that more than 75% know what Twitter is? So yes, it does appear that more than 75%. You'd say yes. Why? Because the range, the interval 0.828 to 0.872 is entirely above 0.75. So that should be your answer for C that you've written down here. And then for D, should be writing this down. Let's get someone to read this one. How about Kristen, can you read for us?
Example continued. D, here is one statement that summarizes the results. 85% of US adults know what Twitter is. That percentage is based on a Pew Research Center poll of 1,007 randomly selected adults. In theory, in 95% of such polls, the percentage should differ by no more than 2.2 percentage points in either direction from the percentage that would be found by interviewing all adults in the United States.
Perfect. Thank you so much. All right, so you should have at least the first paragraph, and then you can say, based upon a 95% confidence interval with an error, margin of error of 2.2%. You can do that instead if you wanted to. Something along these lines you should have written down in there, at least the first 2 sentences, like I said, and then you can add in, instead of writing the whole thing, you can say, this is using a 95% confidence interval with an error of 2.2 percentage points, or 2.2%. All right, so now I'm going to let you guys loose on your lab problem number 1. You can also take a bathroom break if you need to. I'll let you guys hop you guys in. Like I said, I'm going to put you randomly into rooms for today. And I chatted you already your Zoom boards. So go ahead and hop in there and go to the bathroom if you need to first, and then work on this. Oh, wait, hold on. Before you go, let's go over a few things really importantly. The first thing is, what is our N? What is our P hat? That means, what is our Q hat? What is our critical value? Yeah, what is our critical value? What is our confidence level? So then what is our critical value? So let's see if we can find, quickly, let's try to find those things. So what's our N, guys?
1,898.
If our sample size, survey of, that's your N. And then what's our P hat? Our proportion?
0.45.
0.45. So then from that, we can find our Q hat, right? If our P hat is 45%, our Q hat should be 55%. And then my confidence level is 95%. So look up at the table and you guys should be able to find your critical value. Everybody good? So make sure you write these things down and then hop off to your room and check in with your neighbors. Make sure you all have the same numbers for those.